Hello, just want to do a little quickie on the MBE LS-10 degree. This is using the dart casting. We get these raw, they have no C-bores, guide bores, spring pockets, everything like that. That way we can just keep the tolerances that we want. That ensures it. But large valve, 2300 intake valve, inch 625 exhaust. So these are great for power adder applications, as this one is. This is a power adder application. You can see the hoops that we put in it. So this head is basically ready for assembly. So this is for an endurance application. These are for Adam Ofsted. Tom at Tom's Performance in Vancouver, Washington is building this build. We have been dealing with, working with Tom and his son Josh in this build. They have been nothing but professional. I would suggest anybody to go to them. Very professional, and more importantly, very knowledgeable. They've been very nice to work with. But you can see here, just the typical MBE machine work. We certainly pride ourselves in. You can see nothing's a rush. See the CNC lines. They're not spread apart, because when you do that, it makes it less time. But even though as much product as we do, we are not a production shop. We're about making power here. So, it does have a fair amount of rocker arm attachments here. Maybe not as many as some of the other MBE applications, but at least it's decent. At least it's not a single bar with 8. This has hat washers in it. So these are the machine hat washers. These are specially heat treated. They will not gall at all or make that awful sound when you tighten them and they just squeal. So we make all of these, and we press all those in. But you got an intake port over 480 CFM on a 1020 bench. So on a 600 flow bench, probably in the 490 range, maybe a little more. Exhaust though on this is over 300. It's got a fair amount of cross sectional area. This will also work for normally aspirated applications that have enough cubic inch or RPM that they're going to run. Because as we speak about in the other videos, cubic inch and RPM are what dictates how big the ports are in the cross sectional areas within the port. But you can see this has a lot of cross sectional area. You can see in the intake port, the port does not change shapes, and that makes it efficient. And the common wall is straight, which makes flow numbers, which in essence makes power. Maybe flow numbers aren't everything, but when the port is designed correctly, I would say especially on the intake side, the flow numbers are important. And that's it. That's the MBE LS-10 degree. And thanks for joining us.